Hello students. So today I am doing class for class 10, that is the chapter Similarity. We'll do theorems on similarity today. So what do you mean by similar figures? What do you mean by two figures are similar? Suppose you have two triangles. Okay, this is one of the triangles and this is another triangle. This is a smaller triangle and this is bigger triangle. So these are similar triangles. How are they similar? Similar means same type, right? So this is A, B, C. This is also A, B, C. Suppose this length is 3. Suppose this length is 3 centimeter and this length is 6 centimeter, right? Suppose this length is 5 centimeter and this length is 10 centimeter, right? And suppose this length is 7 centimeter and this length is 14 centimeter, right? So these two figures are of same type. They are said to be similar. त्यस्तै टाइपको फिगरलाई चाहिँ हामी के भन्छौं? Similar triangles भनेर भन्छौं. So these two triangles are similar. फेरि यसमा के भयो भन्दाखेरि यो दुईटा एंगल पनि इक्वल हुनु पर्यो. यो दुईटा corresponding angles are equal अनि these two angles are also equal and these two angles are also equal. So this type of two figures are of same type and these are known as similar triangles. The similar triangles भनेको त्यस्तै टाइपको फिगरलाई चाहिँ हामी के भन्छौं? Similar figures भनेर भन्छौं. जस्तै अर्को एक्जाम्पल छ. Suppose एउटा स्क्वायर. Suppose this is one of the squares. So this is another square. So this is the biggest square among all these three. Suppose this is a square whose each length is 3 centimeter. So this is a square whose each of this length is 6 centimeter. And this is the square whose length is each 8 centimeter. So they are of similar type. All these three figures are of same type and these are known as similar figures. Okay. So now today we are doing theorems on similarity. That is similarity between two triangles. Okay. So now the question here is, so this is the geometry portion. So now we are doing theorem on similarity, right? The question is, in any right angle triangle, you know right angle triangle, if one of the angles of a triangle is 90 degrees, then it is known as a right angled triangle. Okay. So in any right angle triangle, if a perpendicular is drawn from the right angular point on hypotenuse. Now a perpendicular is drawn from the right angular point on the hypotenuse. So you know in a right angle triangle there will be a hypotenuse and the opposite angle of this hypotenuse is 90 degree. Okay, the angle opposite to this hypotenuse will be 90 degree and from that right angular point a perpendicular is drawn on the hypotenuse. Okay, then you have to prove that the two triangles on both sides of the perpendicular are similar and each of them, that is each of the two triangles, is similar to original triangle. Okay, now in this case from the right angular point you have to draw a perpendicular upon the hypotenuse. So then you will get two triangles on each side of this perpendicular. You have to prove that these two triangles on each side of the perpendicular are similar to each other. And also you have to prove that each of these two triangles is similar to the original triangle, that is right angled triangle. So is the question clear to all of you? So I think you have understood it. Now let us prove this theorem. Okay. Now first of all you have to draw a right angle triangle, right? So this is a right angle triangle. So this is a right angled triangle. Okay. So this is your 90 degree, right? So A, B, C. So ABC is a right angled triangle. And the side BC, which is opposite to this 90 degree, is known as hypotenuse. यो BC length लाई चाहिँ हामी के भन्छौं? Hypotenuse भनेर भन्छौं. त यो hypotenuse चाहिँ के हुन्छ? It is the greatest side of the right angled triangle. This is the side BC, which is opposite to this 90 degree. So this BC is known as what? Hypotenuse. So either AB is base or perpendicular, or AC is base or perpendicular. If you take AC as perpendicular, AB will be the base, or if AB is taken as the perpendicular, AC will be the base, right? So now from the right angular point, which is the right angular point here? Here angle A is 90 degree, so this is known as right angular point. And from this right angular point, you have to draw a perpendicular here according to the question. Suppose this is AD. So from the right angular point, that is A, because here angle A is 90 degree, so that's why this angle A is known as the right angular point. So from this point A, you draw a perpendicular AD upon BC. Now what is to be proved? You have to prove that, so there are two triangles formed on each side of the perpendicular AD, isn't it? That is, ABD is one of the triangles and ADC is another triangle. You have to prove that these two triangles are similar. That means they are of same type. Okay? And also you have to prove that these two triangles are similar to original triangle. Original triangle means ABC is the original triangle. Now you have to prove that this ABD and original triangle ABC are similar, and also you have to prove that this triangle ADC and original triangle ABC are similar. That means you have to prove three parts here. You have to prove that triangle ABD and triangle ACD are similar. The next, triangle ABD and the original triangle ABC are similar. And then you have to prove that triangle ADC and original triangle ABC are similar. So I think you have understood it. So let us prove it. Let us write down the given here. Your given is, so what is given here? ABC is a right angled triangle. ABC is a right angled triangle with angle A is equal to 90 degree. With angle A is equal to 90 degree. Okay, that means point A is the right angular point. Now from A comma, the perpendicular AD is drawn upon BC. So ABC is a right angle triangle with angle A is equal to 90 degree. This is from, and from A comma, the perpendicular AD is drawn upon BC, right? So now to prove, so here you have to prove the 3 points. Number one is triangle ABD. This is a triangle, right? So it is read as triangle. So triangle ABD is similar to triangle, which triangle? ACD. So these two triangles on each side of the perpendicular AD are similar to each other. That means triangle ABD is similar to triangle ACD, right? And then next, number 2, triangle ABD is similar to original triangle. Which is original triangle here? ABC. Triangle ABD is similar to triangle ABC. That is your original triangle. And then number 3 is your triangle ACD is similar to original triangle, that is ABC, right? So number 1 you have to prove is triangle ABD is similar to triangle ACD. Number 2, triangle ABD is similar to triangle ABC. And number 3, triangle ACD is similar to triangle ABC. Okay, now we will prove it, right? Now, proof. So no need of construction out here. So proof is now how will you prove this? 3 points. Okay. So now in this case, let us first prove that this triangle ABD is similar to original triangle. This is ABC. Okay. So let us write here. Let us draw the figure again in the rough part. So you don't have to draw it. Just try to understand it. Okay. So this is your triangle. I have taken out this triangle ABD, right? So this is your ABD part. This is one part of the triangle, that is ABD. And let us draw this whole triangle. So whole triangle means triangle ABC, right? So ABC, ठीक छ? तो यो बुझ्नुलाई चाहिँ मैले यो दुईटा ट्रायंगल यहाँ बनाउँदै छु. I am drawing these 2 triangles in the rough part. Okay? किनभने हामी यो बनायो भने चाहिँ हामी सजिलै यहाँबाट बुझ्न सक्छौं. यो दुईटा ट्रायंगल चाहिँ कसरी चाहिँ सिमिलर हुँदैछ. So if you want to prove that these 2 triangles are similar, you have to prove that their corresponding angles are also equal. You have to prove that their corresponding angles are equal. So how can you prove it now? So proof in triangles, which 2 triangles? ABD and ABC. ABD and ABC. Which angles are equal here now? You know that this angle is 90 degree, right? And this AD is drawn perpendicular to BD. That means angle ADB is also 90 degree. That means these 2 angles are equal, isn't it? So angle ADB from this triangle is equal to angle BAC from that original triangle, right? Angle BAC, both are 90 degree each. Both are 90 degree each. Okay? And this is angle B, this is angle B. This is the same angle, isn't it? Same angles are there. That means they are automatically equal, right? So angle ABD is equal to angle ABC. Is that clear? Is that clear to all of you? Because these are the same angle. So these 2 angles are equal. Now what can you write? These remaining angles must be equal, isn't it? Since these 2 corresponding angles are equal, these remaining angles must be equal from both these triangles. Okay? So you have to write remaining angle, that is your BAD. That is remaining angle BAD. This angle is equal to this angle, right? Is equal to remaining angle. Which angle? ACB. So I think you have understood it. So since their corresponding angles are equal, so therefore the 2 triangles are similar. Therefore triangle ABD and triangle ABC are similar. So is that clear to all of you? So we have proved this part. So we have proved it. right? So next we will prove that this triangle on the right hand side of AD, that is triangle ACD, is similar to whole triangle ABC. Okay, now again similarly we'll draw it here so that you can understand it. So let us take these two parts of the triangle, that is, one is ADC, this is your ADC, right? This is triangle ADC, this is your 90 degree because AD was drawn perpendicular upon BC, right? And then you draw the whole triangle. So this is your whole triangle, okay, original triangle, right? A, B, and this is C. Now we know that this is 90 degree, right? So that means these two angles are equal, right? And these are the same angle out here. Now these are the same angle out here, and the remaining angle must be equal. These are the remaining angles, okay? So in this way we can prove that these two triangles are also similar. So let us write it here. Again in triangles, that is your ADC and original triangle, that means ABC. So you have to prove that these two triangles are also similar, right? So in this case, angle ADC, that is angle ADC is 90 degree, which is equal to angle BAC, which is equal to angle BAC, that is 90 degree each. That is 90 degree each. Now these angles C are same angle, isn't it? That means obviously they are equal, right? So angle ACD is equal to angle ACB because they are same angle, right? Next, these are the two remaining angles. So two remaining angles must be equal. So remaining angle DAC, remaining angle DAC is equal to remaining angle ABC. Remaining angle, which is the remaining angle here? ABC. That is, in this case, from the figure we can write down that angle ADC is equal to angle BAC, 90 degree each. From the figure you can write it. And these are the same angle here. Angle ACD is equal to angle ACB. Same angles are obviously equal, right? And then the remaining angle DAC is equal to remaining angle ABC from the original triangle, that is ABC. So here also the corresponding angles of these two triangles are equal. That means the two triangles are similar. So which two triangles are similar here? That is triangle ADC is similar to triangle ABC. So that is also proved. So I think you have understood it. Now we have to prove that the triangles on both sides of AD are also similar, right? So now let us prove it. So we can copy it. So now let us prove that the triangles on each side of the perpendicular AD are also similar to each other, right? So now in triangles ABD and ACD, right? So in this case also these two angles are equal, right? Because both are 90 degree. That is angle ADB is equal to angle ADC. Both are 90 degree each. Both are 90 degree each. So in the previous part we have proved that this angle BAD is equal to angle ACD. That means these two angles are equal, right? Isn't it? So in the previous part we proved that angle BAD is equal to angle ACD, right? So angle BAD is equal to angle BAD is equal to angle ACD, and in the previous part also we proved that this angle ABD, that is this angle ABD is equal to this angle DAC. That means angle ABD is equal to angle DAC. So these two angles are also equal. That is angle ABD is equal to angle DAC. And also angle BAD is equal to angle ACD. So I think you have understood it. So these two triangles are also similar because for these two triangles also the corresponding angles are equal, right? So therefore you can write, therefore triangle ABD and triangle ACD are similar. Proved. So we have proved all the 3 points out here. That means we have proved that this triangle ABD is similar to original triangle ABC, and number 2, triangle ACD is similar to original triangle ABC, and both this triangle, that is triangle ABD and triangle ACD, are also similar. Okay, so I think you have understood it. Now we'll do the next theorem. So now, if the two triangles are similar to each other, then their corresponding sides are also proportional. So what is meant by proportional now, right? Suppose there are two triangles, right? So this is one of the triangle and this is another triangle, right? Okay. Now this is your ABC and this is your DEF. This is your DEF. Okay. Suppose this is 3 and this is 6, this is 5 and this is length 10. So this is 3 centimeter, this is 6 centimeter, this is 5 centimeter, this is 10 centimeter, this is your 7 centimeter, and this one is 14 centimeter, right? Okay, so now in this case these two angles are also equal, these corresponding angles are equal, these two angles are also equal, and these corresponding angles are also equal, right? So these two triangles are similar because their corresponding angles are equal. That is, in this case, angle A is equal to angle D, right? Angle A is equal to angle D, and angle B is equal to angle E, angle B is equal to angle E, and angle C is equal to angle F. Angle C is equal to angle F. So their corresponding angles are equal. If their corresponding angles are equal, then these two triangles are similar. That is, triangle ABC and triangle DEF are similar to each other, right? That means this triangle ABC and triangle DEF are what? They are similar. They are of similar type, right? So if they are similar, their corresponding sides are proportional. Proportional means their corresponding sides are proportional means you have to write the sides in terms of ratio. That means AB divided by DE, that is AB divided by DE is equal to, these are the two corresponding sides of these two triangles, that is this AB divided by DE is equal to what? AC divided by DF. AC divided by DF is equal to BC divided by EF. BC divided by EF. That means the ratio of their corresponding sides are equal. That means it is said they are proportional. Their corresponding sides are proportional. So how are they proportional? कसरी चाहिँ यो proportional भयो त भन्दा फेरि AB divided by D भनेको 3/6, isn't it? AB is 3, D is 6. So AB divided by D means 3/6, which is equal to half, right? Because you can cancel it. 3 1s are 3, 3 2s are 6. That is half. Again, AC by DF. This AC by DF. So what is AC here? It is 5 divided by, what is DF there? It is 10. This is also 5 1s are 5, 5 2s are 10, which is also half. That means these two numbers are same. Their ratio are same, isn't it? Isn't it? Similarly, next, BC divided by EF. So what is BC divided by EF? It is also 7/14. That means 7 1s are 7, 7 2s are 14, which is equal to half. That means their ratios are same. If their ratios are same, that is AB by D is equal to AC by DF is equal to BC by EF, then these two triangles, their two sides, then the two triangles are similar and their corresponding sides are proportional. So if the two triangles are similar, then their corresponding sides are also proportional. Okay, so you have to remember this point. The important point here is, if the two triangles are similar, then what can you write? If the two triangles are similar, comma, then their corresponding sides, are proportional. Then their corresponding sides are proportional. That means the ratio of their corresponding sides are equal. Is that clear to all of you? So I think I've understood this sentence. You have understood this point. If the two triangles are similar, then the corresponding sides are proportional. Okay? So now we will prove another theorem, right? The theorem is Pythagoras theorem now. So let us write down Pythagoras theorem. So the question may be state and prove Pythagoras theorem. State and prove Pythagoras theorem, right? State and prove Pythagoras theorem. State and prove Pythagoras theorem. So what is Pythagoras theorem? You should know it. So I think you have done it in class 9, Pythagoras theorem. So suppose you have a right angle triangle, right? Suppose this is a right angle triangle. Okay? So this is A, B, and this is C. Suppose this is 90 degree. And the side AC opposite to 90 degree will be the hypotenuse H. This is the base B, BC, base भनेको आधार, हामी नेपालीबाट आधार भनेर भन्छौं, right? अनि AB चाहिँ के एउटा perpendicular, that is P, perpendicular. AD is drawn perpendicular to BC. So now what is Pythagoras theorem? Pythagoras theorem says that hypotenuse square is equal to B square plus P square. H square is equal to B square plus P square. Pythagoras theorem states that the area of the square on the hypotenuse, that is H square, H into H, okay? The area of the square on the hypotenuse is equal to sum of the areas of the square on the other two sides, that is perpendicular and base. So what is Pythagoras theorem? The area of the square on the hypotenuse is equal to sum of the areas of the squares on the other two sides, is equal to sum of the areas of the squares on the other two sides. On the other two sides means it is perpendicular and base. Okay, so you have to state Pythagoras theorem, and you have to prove that Pythagoras theorem. Okay, so let us write down the statement first. I told you that h square is equal to b square plus p square, right? H square means the area of the square on the hypotenuse, isn't it? Like if you have an square, this is a square, suppose this side is a, this side is also a. So here area is a square, isn't it? Area is equal to length into breadth, but length and breadth are equal here, so it is a square. That's why it is known as area of the square on the hypotenuse. That's why it is written area of the square on the hypotenuse is equal to the sum of the areas of the squares on the other two sides. Okay, so now let us write down the statement of Pythagoras theorem. So statement is, what is the statement here? The area of the square, on the hypotenuse of a right angle triangle, the area of the square on the hypotenuse of a right angle triangle is equal to the, this is the sum, isn't it? Is equal to the sum of the, this is also a square, is equal to the sum of the areas, is equal to the sum of the areas of the square on the other two sides. On the other two sides. So on the other two sides means it is perpendicular and base. Okay, so this is the statement of Pythagoras theorem, that is the area of the square on the hypotenuse of a right angle triangle is equal to the sum of the areas of the square on the other two sides. So this is the statement of Pythagoras theorem. So now let us prove it. Now we will prove this theorem. Okay, now again let us draw a right angle triangle. Now we will prove it. So this is A, this is B, and this is C. So which angle is 90 degree out here? This angle A is 90 degree and this BC will be the hypotenuse. Okay, so here given is so what is given here? ABC is a right angle triangle. ABC is a right angled triangle with angle A is equal to 90 degree. With angle A is equal to 90 degree. That means here BC is the hypotenuse. Okay, so here BC is the hypotenuse. BC is the hypotenuse, and you can take perpendicular either on AB or AC, or you can take base either on AB or AC. This AB may be perpendicular or base, this AC may be perpendicular or base. If you take AB as the base, AC will be the perpendicular. If you take AB as the perpendicular, AC will be the base. Is that clear? So BC is the hypotenuse in this case. Okay, now to prove. So what is to be proved? The area of the square on the hypotenuse, that means BC square, is equal to the sum of the areas of the square on the other two sides. That means AC square plus AB square. That is H square is equal to B square plus P square. So I think you have understood it. Okay. Now construction. Now in this case you have to do the construction step. So now from the right angular point A, draw a perpendicular AD upon BC intersecting BC at the point D. Okay. From A perpendicular is drawn on BC intersecting the hypotenuse BC at the point D. Okay. So from the right angular point, because it is 90 degree, right? From the right angular point, from the right angular point A, the perpendicular AD is drawn upon the hypotenuse BC. Hypotenuse, Hypotenuse, hypotenuse. The perpendicular AD is drawn upon the hypotenuse BC at the point D on it. At the point D on it. So is that clear to all of you? So you can copy it. So this is very, very important question. State and proof Pythagoras theorem. So we have done the construction out here. Okay. So now let us do the proof part. Now we will prove this. Hypotenuse whole square is equal to base square plus perpendicular whole square. Okay. So now let us take these two triangles now. This is triangle ABD. Don't write, just try to understand it. So this is the rough part. Okay. This is the rough work only. This is only the rough work. Just try to understand it. So this is your ABD, right? And whole triangle. Whole triangle, that is, this is your ABC. Whole triangle ABC, right? So this is your 90 degree. This is also 90 degree. So these are the same angle, isn't it? BB, and these are the remaining angles which are always equal, right? Now proof. Now we are taking these two triangles. So we have seen here that these two triangles are similar because their corresponding angles are equal. So you have to write here triangles ABD and ABC are similar. They are similar. I just told you that if the two triangles are similar, then their corresponding sides are also proportional. So let us write here BD by AB. Okay, this is base. BD is the base divided by AB. BD divided by AB is equal to this base divided by hypotenuse is equal to, now which is the base here? AB is the base and BC will be the hypotenuse now. So BD divided by hypotenuse, base divided by hypotenuse, that is we are taking BD divided by AB is equal to, what will you take here? AB as the base and BC as the hypotenuse. So BD, so this BD was the base divided by hypotenuse. Now this AB is taken as the base and BC will be the hypotenuse. Because we have taken here base divided by hypotenuse, on the right hand side also there should be base divided by hypotenuse, right? That is base is AB divided by hypotenuse is BC. So this is AB divided by BC. That means their corresponding sides are proportional. So I think you have understood it. Okay. So next you can cross multiply it. You can write only these two relations out here. Now you can do cross multiplication. AB into AB, that is your AB square. So AB square, AB into AB is AB square, because this is the length or side AB. That's why you have to write AB square. It is not A square B square, right? Because AB is the side here. That's why you have to write only AB whole square. So which is equal to BD into BC. So let us mark it number 1. Okay. So you have understood this one. So again, in the rough part, you have to draw two triangles here again. That is, one of the triangles is triangle ADC. This is triangle ADC. That is the triangle on the right hand side of the perpendicular AD. And then draw the original triangle. Which is the original triangle here? That is your ABC. Okay. So in this case also, this 90 degree, angle D is 90 degree, angle A is 90 degree. That means these two angles are equal. These are the same angle, and these two are the remaining angles, and they should be equal, right? So again, triangles ADC, again triangles ADC and ABC are similar. So if they are similar, their corresponding sides must be proportional. You know that, isn't it? Their corresponding sides must be proportional. So which sides will you take here again? Here also you should take base divided by hypotenuse. That is CD divided by, which is the hypotenuse here, AC, is equal to, on the original triangle also you have to take base divided by hypotenuse. Since we have taken AC here, CD divided by AC, CD divided by AC, CD divided by this AC as the hypotenuse. Now in this case you should write this AC as the base, this AC divided by BC. This is the base divided by hypotenuse. That means here you can write AC divided by BC now. So in this triangle, this AC is the base and BC will be the hypotenuse. In this case, CD will be the base and AC will be the hypotenuse. That means B by H, that is CD by AC, is equal to, now in this triangle, AC will be the base and BC will be the hypotenuse. Is that clear now? So this is CD by AC is equal to AC by BC. Now you can do cross multiplication here also. So it is AC into AC, AC whole square. That is the side. So you cannot write here A square, C square. Is that clear? So it is AC square is equal to CD into BC. So that is number 2. Now we have to prove that relation. What is the relation to be proved? Hypotenuse whole square is equal to base whole square plus perpendicular whole square. That is BC square is equal to AB square plus AC square. Now, how will you prove it? You have to add these 1 and 2. So write down adding 1 and 2. So adding 1 and 2. So what do we get adding 1 and 2? This left hand sides must be added. From 1 and 2, you have to add this 1 and 2. From 1, you have to write down the left hand side, that is AB square, plus, again from 2, you have to write down the left hand side, that is plus AC square, which is equal to, on the right hand side, you have to add those right hand sides from 1 and 2. That is BD dot BC plus, next. So next one is BD dot BC plus CD dot BC. CD dot BC. Okay. As the next part is or. Now write down AB square plus AC square. AB square plus AC square is equal to, now what is common here? That is BC is common here. That is BC is taken common. So within bracket, what do we get? BD plus CD. BD plus CD. Or AB square plus AC square is equal to BC dot. What is that BD plus CD? Look at the figure and tell me. The figure was like this, isn't it? This is A, B, C. This was 90 degree. And from this right angular point, we dropped a perpendicular upon the hypotenuse BC. That is AD is drawn perpendicular upon BC. Okay. Now, looking at the figure, you tell me what is BD plus CD. This BD plus CD is BC, isn't it? BD plus CD is जोड्दा के भयो? Straight line BC भयो. So here you should write BC dot BC. Understood? So next one is, or this is AB square plus AC square is equal to, what is BC dot BC? This is your BC square. This is, BC is also the side of a triangle. So BC dot BC is not equal to B square C square, but it should be BC whole square. Is that clear? अब हामी के गर्नु सक्छौं, यो राइट साइड को लेफ्ट साइड मा, लेफ्ट साइड को राइट साइड मा लेख्दा साइन चेन्ज गरिरहनु पर्दैन, हैन? So what do we get? That is BC square is equal to AB square plus AC square. So it is proved. So Pythagoras theorem is proved. So this is very, very important theorem. That is, state and prove Pythagoras theorem. So I think you have understood it. So you can copy it. Now we'll do the next theorem. So now we'll do the next theorem. So this is the converse part of Pythagoras theorem. The theorem is, if in a triangle the area of a square drawn on one side is equal to the sum of the areas of the squares drawn on the other two sides, okay, then the angle opposite to the first side means this, the area of the square drawn on one side, that will be the first side, okay, then the angle opposite to the first side will be a right angle, okay. So in a triangle, if the area of the square drawn on one side is equal to the sum of the areas of the squares drawn on the other two sides, then you have to prove that the angle opposite to the first side, will be a right angle. Is that clear? So again, in this case, you have to prove that in a triangle, suppose it is given that, so what is given here actually? It is given that in a triangle, the area of a square drawn on one side is equal to the sum of the areas drawn on the other two sides. So then you have to prove that, the angle opposite to the first side will be a right angle. Is that clear? So now, suppose a triangle is given. Suppose this is a triangle, right? Suppose this is a triangle. The triangle here is, this is A, B and C. Okay? So suppose AC is one of the sides. So AC is one of the sides of the triangle. So it is given that the area of the square on the one side, the area of the square on the one side, that is AC, the area of the square on AC is equal to the sum of the areas, on the other two sides, that is AB and BC. This is given. You have to prove that the angle opposite to the first side AC, the angle opposite to the first side AC is this angle B. You have to prove that this angle B is a right angle. That is, angle B is equal to 90 degree. Okay. So again, try to understand it. I'm again explaining you what is given here. The area of the square on one side, that is, one side is taken as AC. The area of the square on the side AC is equal to the sum of the areas on the other two sides, AB and BC. Then you have to prove that the angle opposite to the first side, is this angle B. You have to prove that this angle B is a right angle. That means you have to prove this angle B is equal to 90 degree. Okay, so what is given here? AC square is equal to AB square plus BC square is given. You have to prove this. The angle opposite to the first side AC will be a right angle. That is, angle B is equal to 90 degree. So this is just the converse part of Pythagoras theorem. Okay, in the Pythagoras theorem, what was given? In Pythagoras theorem? This angle B is 90 degree. This angle B is what? 90 degree, and you have to prove that AC square is equal to AB square plus BC square. But this is the converse part. In this case, what is given here? AC square is equal to AB square plus BC square is given. You have to prove that this angle B is 90 degree. Is that clear to all of you? So let us prove it. So let us write down given ABC is a triangle. So what is given here? ABC is a triangle in which AC square is equal to AB square plus BC square, right? So this is given. That is, AC square is equal to AB square plus BC square is given. So to prove, so what is to be proved? To prove that, what is to be proved? The angle opposite to the first side AC will be a right angle. That is, angle B is equal to 90 degree. That is, angle ABC is equal to 90 degree. You have to prove it. So in this case, you have to do the construction part. Let us do the construction now. Now construction part. Okay. Now let us draw a straight line. Let us draw a straight line DE. Let us draw a straight line. Let us write it as DF. A straight line DF is drawn making equal to BC. Okay? हामीले एउटा straight line DF बनाउँदै छौं जसको लेन्थ चाहिँ BC सँग इक्वल होस्. बुझ्दैछ? त्यहाँदेखि हामीले के बनाउँछौं भन्दाखेरि यहाँ let us draw ED which is perpendicular to DF. Let us draw ED. Let us draw ED which is perpendicular to DF, making ED is equal to AB. Then join E and F. Then join E and F. Again, look at the blackboard. So what is the construction out here? Let us draw the straight line DF making equal to this straight line BC. Now let us draw a perpendicular ED which is perpendicular to DF, making ED is equal to AB. Then you have to join E comma F. Is that clear? So now construction is a straight line, DF is drawn. DF is drawn making DF is equal to BC. Making DF is equal to BC. So now ED is drawn perpendicular. Now ED is drawn perpendicular to DF. Perpendicular to what? DF. Perpendicular to DF, making ED is equal to AB. Making ED is equal to AB. Okay? These two sides are equal. These two sides are also equal. Right? That is, here BC is equal to DF and this AB is equal to ED. Is that clear? Now you join E comma F. So E comma F are joined. E comma F are joined. Okay? So, since this is perpendicular, ED is drawn perpendicular to DF, so EDF is a right angle triangle. Okay? So now in the proof part, you have to prove this triangle ABC is a right angle with angle B is equal to 90 degree. Now let us prove it. Okay? So now we'll do the proof part. अब हामी प्रमाण गर्छौं कि यो एंगल B कति हुन्छ भनेर 90 डिग्री हुन्छ भनेर हामी प्रुभ गर्छौं ठीक छ So now in this case proof since triangle DEF is a right angle triangle, is a right angled triangle, isn't it? Triangle DEF was drawn in the construction part. So triangle DEF is a right angled triangle. So therefore what can you write here? Hypotenuse whole square, that is from the previous theorem. So if it is a right angle triangle, you can write down that hypotenuse whole square is equal to base whole square plus perpendicular whole square, isn't it? That is EF whole square is equal to what can you write? ED square, that is perpendicular whole square plus DF whole square. It is DF whole square, right? So this is from right angle triangle. So now what was given here? What was given? ABC in triangle ABC, AC square is equal to AB square plus BC square. It was given that, isn't it? Now what is given here? AC whole square is equal to AB square plus BC square, right? So or AC square is equal to, now from the figure you can write down that this AB is equal to ED, isn't it? In the construction part we have drawn it, that is AB is equal to ED, that is this is your ED square plus, and also BC is equal to DF. That means instead of BC what can you write? It is DF square. Is that clear? So now next, or AC square is equal to, what is ED square plus DF square from this part? It is your EF square, isn't it? So it is EF square. Now taking square root on both the sides, what do we get? That is AC is equal to EF. These sides are also equal. These sides are also equal. Okay? So now in order to prove this angle B as 90 degree, let us prove that these two triangles are congruent. I told you the meaning of congruent. Congruent means equal in all respects. That means equal in all sides, equal in all angles. Okay? Now in triangles ABC and EDF. So in order to prove that these two triangles are congruent, that is equal in all respects, you have to give the three reasons in this case. So what are the three reasons in this case? AB is equal to ED, that is the first. BC is equal to DF, that is the second reason, and AC is equal to EF, that is the third reason, right? So one is AB is equal to what? ED. Next one is BC is equal to DF. BC is equal to DF, and AC is equal to EF. So because of these three reasons, that is SSS property, side property. So from these three reasons, what can you write? These two triangles are congruent. So congruent ko sign kasto huncha थाहा छ? That is triangle ABC is congruent to triangle EDF. So triangle ABC is congruent to triangle EDF. यसको meaning के रहेछ? अस्ति पनि मैले भनेको थिए, यसको meaning के हो? Congruent. Congruent भनेको equal in all respects. Is that clear? Equal in all sides, equal in all angles. That means this angle EDF is 90 degree. So angle ABC is also what? This should be 90 degree. So we can write here. So therefore angle ABC is equal to angle what? EDF, because they are equal in all respects, right? So what is angle EDF there? By construction we have drawn here angle EDF is equal to 90 degree. That is angle ABC is what? This is 90 degree. So it is proved. So I think you have understood it. So this theorem is the converse part of Pythagoras theorem. Okay. So I think you have understood all the problems that we did today. So you revise it at home. So this much is for today. Okay.